Okay, so we're looking at functions that are not straight lines now, and we've got a range of functions that we'll cover over the next few videos. So the first one are called exponential functions, and it really is growth functions. Okay, so what I want you to do is on your calculator, see if you can find the button that is X with a little square. If you don't have it, you might have a V, but most kids on the Cascades will have that button. So what we're going to do is we're going to put this number to a power where the power is these numbers here. So for instance, we're going to put 2 to the minus 2, 2 to the minus 1, 2 to the 0, 2 to the 1, and 2 squared. So I want you to do that on your calculator and see if you can get 5 answers. So can you do that now and pause the tape? Okay, so you should have got 0.25, 0.5, 1, 2, and 4. Like 2 squared is 4. Okay, so when you plot it, okay, here's minus 1, here's minus 2, here's 1, here's 2, 1, 2, 3, 4. Okay, so the first value when we plot it is probably about there, a quarter, and then a half, and then 1, and then 2, and then 4. So we don't use a straight line, and what's going to happen is it's going to have values behind minus 2. And it's going to look like that, and it's going to go up really sharply, and on the other side it's going to go down very small. Okay, so that's our first one. So finish that off, copy that down and come across when you're ready. So let's try it now with 3 to the x and see what happens. So use the same values, pause the tape, and when you're ready, come back in. Okay, so we'll do these ones, 1, 3, 9, and this should be 0.33, and I think this is about 0.11. Okay, so now this time, because it's going up to 9, I might go up in 2s, 4, 6, 8, 10. It's just a sketch, it doesn't have to be picture perfect. So this time 1, and then 3, and then 9, and then 0.33, and it's going to be really small on that side. Again, we've got the same sort of shape where it goes up really sharply after you go past 0, and it's really small on the other side. Okay, so you should have got that when you're ready to come across. And so what we're going to do now is talk about a general formula. Okay, so this number was 2 or 3 or could be anything to the same power, and what we've got is this shape here where it crosses at 1, and then after it goes past 0, it just goes up really sharply. But on the other side, it just gets smaller and smaller. So here are the general features. Okay, so the general features are it always has a y-intercept of 1. You don't actually cross the x-axis. You don't cross it. You can't have anything. You can't have any y values that are negative. We won't get there. The curve is continuous in both directions. And as x gets bigger, y gets really big. This symbol here is called infinity. So as x gets bigger, y gets really big. Okay, so we approach infinity. But as x gets smaller, y approaches 0. So as you go backwards this way, the curve gets closer and closer to 0. But it actually doesn't get there. Okay, so copy that and then come across. So we've got a couple of changes that we can have. So if I put a negative x, the curve goes the opposite way. Okay, it still passes through 0 at 1, but instead of going up to the right, it goes up to the left. If I put a minus sign, what happens is the curve gets flipped. So instead of going through at 1, it goes through at minus 1. Okay, so that's really a pretty simple one. And the other one we want to do is if we add a number at the back, what happens is the curve just gets pushed up. Okay, so if you add something at the back, the curve just gets pushed up, and whatever that value is, where it crosses the y-axis will be that value plus 1, because it starts at 1 and it gets pushed up to 2 or whatever. Okay. So instead of the curve getting closer and closer to the x-axis, it gets closer and closer to that b value. Okay. What else have I got left? I think it might be it. So there'll be an exercise on Moodle. Okay, so they're the easy ones. So there'll be an exercise on Moodle that you have to do. Okay, thanks. Bye.